Circuits that can be printed and used on materials including fruit, fabric, and plastic. Do you recall iron-on decals? All you had to do was use a home printer and special paper to print something, then use an iron to transfer it to a t-shirt. Scientists have now created a very similar method, although it prints circuits rather than images or logos. The technique can print functioning circuits onto a variety of objects, including ukuleles and teacups, as described in ACS Applied Materials and Interfaces. Circuit boards that manage electronics are developing at the same rate as electronics themselves. Today's boards are typically robust and constructed with strong fiberglass backings. Electronics must be flexible because they are integrated into floppy and pliable objects, such clothing and soft robots. A specific alloy of gallium metal that is a liquid at ambient temperature is frequently used in liquid metals circuits as a result of this, which has raised interest in them. These gadgets can be created by printing them out using a modified inkjet or 3D printer. However, these procedures call for time-consuming steps and expensive machinery, making the finished products pricey and unsuited for mass production. Xian Huang and colleagues sought to create liquid metal circuitry using a desktop laser printer that could print the electronics onto a variety of surfaces in order to accelerate, simplify, and reduce the cost of the fabrication process. The researchers used a regular laser printer to print a connected design onto heat-transferable thermal paper to generate the circuits. The glass pane was transferred to by heating the carbon-based toner that had been applied by the printer. Between the carbon and the liquid metal, the toner patterns roughened the surface and generated a hydrophobic air gap. The electronic ink-based pattern only attached to the exposed portions of the surface as a result, preventing the metal from sticking when it was brushed on top. Then, this circuit might be directly adhered to a flat surface, like a plastic soda bottle. The device was initially placed on a piece of flexible plastic, then onto the rougher surface, if the surface was too uneven, like the bumpy orange skin. Nevertheless, the basic electronics all worked as intended on the various substrates to which they were connected, whether they were used for image display, RFID tagging, temperature sensing, or sound amplification. According to the experts, this procedure ought to significantly increase the applications for liquid metal circuits.